Today our topic, our Common Core topic is functions, so it's F, interpreting functions IF, so it is going to be understanding linear functions and we'll interpret statements that use linear functions. All right, what does that mean? Well, let's take a look, okay? Anytime you see linear, always remember linear means line, which is straight. Who said that? Totally right. Yeah. It's a straight line. Linear, you see the line. Anytime you see a linear function, the line is totally right. It means a straight line, okay? All right, example 1. So find the equation of a line with slope of 2/3 passing through the point -312. Now there's two ways to do it. One is to get out a piece of graph paper, put a point at -312, which is way up there, and then just start doing the up 2 over 3 over 2, 3 and draw the line and figure out what the y-intercept is. That is one way to do it. However, there's a formula that's kind of handy. We could use our y equals mx plus b formula. Okay, that's one way. Or, I've got another one. The one I like, personally, is the y minus y1 equals m times x minus x1. Okay, that's the equation of a line. Equation of a line from a point and a slope. Okay, it's called the point-slope formula. Okay, Elijah, turn around, point to the top of the building, right there, top. See it? So you've got up on the top of that board, you've got equation of a line. You see two different equations. Y equals mx plus b, that is one equation of a line. And we've got the other, y minus y1. Now a lot of kids haven't seen this one. We saw this a little bit in Algebra 2, right? Saw a little bit in Algebra 2. I like this one. I think you're going to see why I like this one. It's called the point-slope formula for a reason. We have a slope and we have a point. And in this equation, this example, we've got a slope and we've got a point. So every point has a x, y value, right? So I'm going to take my 12 and put it in for y1. Take my -3 and I'll put it in for x1. And I'll take my 2/3 and put it in for m. Now the y and the x are variables. They have to be there to get an equation, right? So this y and this x are variables. They stay because we need it to have an equation. x1, y1 are the point, and my slope is 2/3. So I'm just going to plug those in. Rewrite this then as y minus 12 equals 2/3 times x minus a -3, double negative, okay? So I just plugged in the 12 for the y1, plugged the 2/3 in for the m, the slope, and I plugged in the -3 for x. Now I'm just going to solve for y. I'm going to simplify and solve for y. All right. First of all, double negative, let's make that a plus plus. You okay with that? Double negative there. Subtracting -3 is like add a 3, right? And I'm also going to distribute. I'm going to go 2/3 times x and 2/3 times 3, all right? All right, I'll slide down the y minus 12. I'll distribute. 2/3 times x is a 2/3 x. 2/3 times 3, well, here's how I do it. 3 goes into 3, 1 times 2 is 2. Or you can go 2 times 3 is 6 divided by 3. Either way, it's 2. All right? 2 times 3 is 6 divided by 3 is 2. Plus 12, I get y equals 2/3 x plus 14. That is the equation of the line with slope 2/3, and it will pass through the point -312. It really will. We just don't have to graph it to show it. All right? So here's the key. We used the point-slope formula. So let me go ahead and highlight that. Here's our point-slope formula. It's y minus y1 equals m times x minus x1. Okay. Example 2. So example 2, same thing. We want the equation of a line. So when I see we want the equation line, I'm going to use my y minus y1 equals m times x minus x1. So when I see the word, find the equation of a line, okay? When I see equation of a line, I want to use this formula, okay? Now, in this example, though, I don't know the slope. I need to find m. So this is a two-step problem. So this takes 2 steps. 2 steps. So first of all, we need to find the slope. Okay, and the slope is, Brooke, point behind you. Go ahead, turn around, point up behind Brooke. Guys, see above the door? And if you don't know the slope formula, there it is. Slope formula is y2 minus y1 over x2 minus x1. Okay, that's the slope formula. Every point has an x and a y value, right? So if this is my first point, that's x1, y1. This would be my second point, so that's my x2, y2, okay? So if I use my formula, I take the y minus the y over the x minus the x. So I'm going to do. I'm going to take the y minus the y over the x minus the x. So my slope formula is going to be m equals a 1 minus 5 over negative 2 minus 3. Okay? And we'll simplify that. That'll be a negative 4 over negative 5 or 4/5, okay? Okay, that's my slope, right? So now we've got my slope, and I want to use, remember I told you it's a two-step equation. So now let's take our 4/5, let's plug it into here. Let's take our point and plug it into our equation of a line. So I'm going to take a y minus. Now I can use either point, but I usually use the first one. Okay, either point works, but I'll probably take the first one. So I'll go y minus 5, because that's my y value, equals my m, which was my 4/5, times my x minus 3. Totally right, okay? Now I might have a decimal. I can handle decimals. That's not going to scare me because I have a calculator. So let's distribute. So I'm going to take 4/5 times x and 4/5 times negative 3. So I'll have a y minus 5 equals 4/5 times x is a 4/5 x. And 4/5 times 3, well, let's check it out. Let's see what the calculator says, okay? So what is 4, hold on, clear parentheses, 4/5 times negative 3? I get a negative 2.4. Okay, I don't mind decimals. Have a calculator, no big deal. Okay, plus 5, I'll have y equals 4/5 x, plus 2.6, I think. Okay. That would be the equation that goes through both of these points. That's what our answer is. This is the equation of a line that goes through both of these points. Okay? Thumbs up. Sideways where I'm at. Okay? Okay? Alright. Example 3. Alright. So a dam is built on a river to create a reservoir. The water level, h of t, which is, here's where function notation makes sense. H of t, listen in, height over time. Think about it. Height over time. The dam's raising, so the ht means something. It's the height of the water over time. Okay, does that make sense? Time is the control variable, because the longer the time goes, the more height that goes up, right? Time drives the height, right? At any time, I can go out and see the height. Does that make sense why time drives the height? So, sketch a graph. So, I don't have to do a real fancy graph. I'll screw this over. So, if I do a fancy little graph here, I know it has to start at 28. And it's going to go up. One hour, 2 hours, 3 hours, okay? So what do I know about these numbers, okay? What do I know? So what does the 28 represent?
Starting point.
Starting height, right? I mean, it might have been raising, but when I went out and looked at it, right? I'm the biologist. When I went out and looked at the dam, when I took my measurement, it was at 28, right? And then I noticed, what's the 4.5? What did I notice? What's the 4.5?
How much is raising?
Raising per hour, right? Okay, exactly. So what's the slope? The slope's 4.5. And what does it represent? It represents 4.5, I assume it's feet per hour, okay? Does that make sense? We saw a SAT kind of like this yesterday, didn't we? Pretty similar to this. So that child's growth, right? It's the same thing where the slope was like a rate, okay? Let's turn the page. guys good? Okay. All right. Example 4. Water is being pumped into a swimming pool at a rate of 5 gallons per minute. Initially, the water level started at 200 gallons. So, let's do a linear model. I like to use variables that make sense. Okay, so water or gallons, right? We got gallons and 5 gallons per minute. So I'm going to go G of T. Gallons per minute. G of T. You okay with that? G stands for gallon and T. So it's the gallons with respect to time. Equals, well, our rate is 5 gallons per minute, so I'll go 5t, right, plus 200. All right, it's finally summer. We can put water in the pool and play, right? We had 200 gallons in, now we're going to add water. However, I'd probably drain the pool first if it was the first time out, but you know. Anyway, if the pool has 600 gallons, how many minutes have transpired? So, this is easy, because when we start to use variables, it's really easy. Where do we put the 600 in? For G, don't we? So we'll go 600 equals 5t plus 200. So when you use the right variables, you don't have to guess where the numbers go. You just put it in for G, right? All right, minus 200 minus 200, so I get a 400 equals a 5t. Divide by 5, and I think we get 20, don't we? Right? No, 80. 5 goes in 80. 80. There we go. So how many minutes? 80 minutes. Pretty easy. Told you today was easy. Compared to like a couple of days ago, we had to graph those weird graphs and use the calculator, right? All right. Example 5. John and Mary are traveling westward at constant speeds. Okay, the graph shows their distances and time. So first of all, if you look at this graph, before we do anything, can you tell me something about John and Mary? Okay, just come on, use a little bit of. It's okay to guess wrong. If you look at the two graphs, what do you notice? Can you tell me anything about these two graphs?
John starts higher.
Okay, John starts higher, which means John got a head start. Does that make sense? So maybe Mary's at home and John's at 150 miles ahead when they start, okay? Who's going faster? Mary. Why do you know Mary's going faster?
The rate of change.
Rate of change is greater than the rate of change here. Or better yet, let's use some easy words. The graph's steeper, right? Isn't the graph steeper? So if the graph is steeper, the slope is bigger. If the slope is bigger, the rate is bigger, which means rate is speed, right? There you go. Okay, great. Okay, what speeds are John and Mary traveling? So first of all, let's do speeds. Now we know that rate is equal to distance over time. Or in this case, it's just the slope, isn't it? Isn't the speed just the slope? Rate is a slope, okay? So let's do first John. John seems to be going up 100. Let's see, we go 100. I've got 150, right? Maybe 150 in 2 hours. So John's, let's see, he's going from 50. It is 100. You're right, I'm wrong. 100. I got to be able to.
150 up to 250.
Yeah, so we're going from 150 to 250, so it goes 100 in 2 hours, right? So his rate's 50 miles per hour. Now, if I could see, I would have got that, right? How's Mary? What's Mary's rate? She's going up 150 in 2 hours, right? 150 in 2 hours. Or her rate's 75 miles per hour. She's speeding, huh? Yeah. I know nobody ever speeds in this classroom. Heck no.
No, of course not.
Okay. So, now find a function. So, what we've got is, we've got distance and time, right? So, let's do d of t, distance, because we are going distance, right, in time, is equal to, let's see, we'll do John first. So what was John's slope? What was John's rate? 50, right, Alondra? 50 t, and John got a head start, right? So John started at 150. Capiche? All right. Mary, how about Mary? D of t, distance with respect to time, is equal to what? What's her rate or her speed? 75. 75t plus 0, right? Okay. Okay, how far will John and Mary travel in 5 hours? That's easy. Plug it in, right? So for John, we'll go d of 5. So Carmen, this is what the whole thing is. D of 5 means plug in 5, right? So d of 5 means 50 times 5 plus 150. Oh, what's that, 250? Is that 400? So 400. Hold on, I'll do it real quickly.
400.
400, okay. So that means d of 5 equals 400, which says after 5 hours, he's gone 400 miles. And with Mary, we'll do the same thing. We'll go d of 5 is equal to 75 times 5, and it's 350, okay? So then,
375.
375?
375.
I'm going to believe you, okay? So d of 5 equals 375. So she hasn't caught him yet, has she?
No.
She hasn't caught him yet. So how can we find out when Mary will pass John? We can guess, but what's a better way? You could graph it, yes, I could extend the graph. What's a better way? There you go. Because when she passes John, she's equal to John. Does that make sense? The moment she passes John, at that moment their distances are equal, right? So set them equal. Thanks, Sarah. So we're just going to take the two equations. We're going to go our 50t plus 150 equals our 75t. We'll solve for t. Minus 50t minus 50. I got 150 equals a 25t. Divide. I think I get 6, don't I? Divide. I get t equals 6 hours. Okay. It's going to take her 6 hours to catch him, but she is moving fast. Okay. So again, same thing. Not a lot of homework. Okay. I'll stop the recording.